Okay, we're going to talk about the shell method. If you think of a roll of paper towels, now I'm not good in drawing in 3D, but here's their inner part of the paper towel. There's no towels there, and the towels go around it. The towels go around. That is, it's a cylinder with a hole in the middle. Now, what we want to do is we want to add up the volume of this paper towel, of the roll of paper towels. Possibly I can get a better diagram. You have the cardboard that the paper goes around, that's this, and then you, in fact, have the paper. Okay, it's like two cylinders in one. Now, imagine you want to unroll the paper towels and you want to find the volume. Well, say at the beginning of the roll, the radius is R. So, and the height is H. So what you're going to get is, when you unroll one piece, the length is going to be 2 pi r, and the height is going to be h. And that's basically what we're going to do. And the paper will have a little thickness to it, called the thickness delta x. So you multiply the three sides. See, you get 2 pi r h delta x. And then when we add them all up, we put integral, and instead of delta x, we put dx. In any case, this here is the formula. The radius, or r, is how far you are away from where you're revolving. We are going to revolve around the x-axis, say. And the last roll, the last sheet of paper, is going to have a radius of, say, r. R is going to change. And the height is going to be whatever it is. And the paper towels, if you take a knife and you cut the top might look like that. So the heights will be different. The height will be h of x. And if we're revolving around the x-axis, it'll be dx. Okay, let's try an example. Suppose you want to find the volume of a solid, a revolution formed by revolving the region bounded by y equal x minus x cubed, and the x-axis. And the x-axis. And we are going to revolve about the y-axis. We're going to revolve around the y-axis. Well, we should graph this. In order to graph it, it might be helpful to know the zeros. To factor y equal x minus x cubed. Excuse me, that should be a 1. When we pull out an x, we get x times 1 minus x squared. But what's in the brackets is the difference of squares, because 1 is the same as 1 squared. It's the difference because of the subtraction symbol. Write down the things that are being squared, namely 1 and x. 1 and x are being squared. Write them down twice. 1 gets a plus, 1 gets a minus. Now, this equals 0 when either this factor is 0, and that's when x is 0, or that factor is 0, and that happens when x is negative 1. And of course, 1 minus 1 is 0, so the last factor is 0 at 1. And since it's a negative x cubed, I know positive x cubes go that way, negative x cubes go that way. So, I know it crosses at negative 1 and at 0 and at positive 1. and it goes this way. Okay, I meant to say and the positive x-axis. So just to draw this a little bit more friendly for us, let me just extend this higher. So the positive x-axis, well, that means I can ignore everything where the x-axis is negative. Okay. It's bounded by this curve and the positive x-axis. It's bounded by what remains. This area in here. Okay, that's what we are going to revolve about the y-axis. We're going to revolve this about the y-axis. Okay, so let me just get a little bit more space. Let me erase this up here. Now, if you're revolving around the y-axis, or parallel to the y-axis, you put your vertical strips that way. So, it's 2 pi r times h, in this case, times dx, because those are delta x's. Now, what we need to know is that distance, this distance, and that distance is x. That's the radius. So it's 2 pi, which I will pull out in front of the integral. The radius is x, and the height of this strip, well, that's just the y value, which is x minus x cubed dx, and it turns out, remember we said that was 1 already, x is going from 0 to 1. And there's your integral that you need to solve. That's what the volume is going to be. It's 2 pi integral. When I multiply that out, that is, after I distribute the x, I'm integrating x squared minus x to the 4th dx from 0 to 1. This is 2 pi. The antiderivative, or the integral of x squared, is x cubed over 3 minus x5 over 5. And this is from 0 to 1. When I plug in 1, I get 2 pi times a third minus a fifth. And when I plug in 0, I get 0. So the final answer will be 2 pi over 15. 1/3 minus 5/3 is 2 over 15 times 2, and I already put over 15. So it's 4 pi over 15. Okay, let's try another one. The radius is always from the strip to where you revolve, the distance between the strip and where you're revolving around. For example, if y is equal to 1 over x squared plus 1 squared. Now, the numerator is always bigger than 0, and since we're squaring, the bottom's always bigger than 0. It doesn't matter what you really draw, just draw something above the x-axis, because that's where y is positive. Okay, so it's bounded by y equals that, and x is in between 0 and 1. That's what it's bounded by. So, from 0 to 1, maybe it looks like that. Something positive. And I'm telling you, 1 is right there. Now, we are going to revolve this about the y-axis. Revolve about the y-axis. If you revolve it around the y-axis, or even parallel to the y-axis, the strips that you draw are parallel to the line you're revolving around. That's the strip. That's delta x. Now, we know the volume is 2 pi times the integral of the radius. The radius is the distance between where we are revolving around, the y-axis, and the strip. Well, that's just x. And the height of this strip is just y, or this. 1 over x squared plus 1 quantity squared times dx. And dx is going, or x is going between 0 and 1. So, to clean this up a little bit, multiplying the numerators, x times 1 times dx, well, that's just x dx. Now, if I call the denominator u, if I call part of the denominator u, well then du is 2x dx. The bottom, well there's the 2 pi. The bottom, the denominator, well that's u squared. U squared. And the numerator, well, if I put a 2 in front, then I'll have 2x dx, but that's du. That's du. But in order to put a 2 in the front, I have to counter it by putting a 2 inside the integral sign. In the numerator, I have to counter that by putting a 2 in the denominator in front. Coincidentally, that canceled out. The 2's cancel out. So basically, you have pi times the integral of du over u squared, which is the same as pi times the integral of u to the minus 2 du. But that's a pretty basic integral. Add 1 to the power, and then divide by that number. Now, pi divided by negative 1 is negative pi times u to the minus 1. But I can write u to the minus 1 in the bottom like that. Okay, now, let's see what we integrate from. When x is 0, how much is u? If x is 0, then u is 0 squared plus 1, or 1. So, instead of integrating from 0, x equals 0, we integrate from u equals 1. And now, when x equals the upper limit, which is 1, then u is 1 squared, which is 1, plus 1 more. 1 plus 1 is 2. So we integrate from 1 to 2. Now, I just hate negative signs. If I change the sign in front, which I just did, then I have to interchange the limits. Instead of going from 1 to 2, we go from 2 to 1. And then we get pi over 1 minus pi over 2, but that's pi over 2. And minus some silly error, that will be your answer. The hardest thing is to know the radius. The radius is the distance from where you're revolving up to the strip. Okay, let's try another one. Find the volume of the solid formed by revolving the region bounded by the graph y equal x squared plus 1, y equals 0, y equals 0, x equals 1, and this is about the y-axis, about the y-axis. So it's bounded by those three curves. X squared plus 1, y equals 0, and x equals 1. Well, x squared plus 1 looks like this, where it has 1. Y equals 0 is this line right here, and x equals 1, call that 1. This is x equals 1. Okay. And bounded by x equals 0, I guess. X equals 0 is this line. So it's the area bounded by the curves in blue. It's the area where if you were in there, you couldn't get out because you have to cross a blue. Like if I'm up here, I can go out. If I'm over here, I can go all over the place. But if I'm in here, I'm bounded by the blue. That's the region we are going to revolve around the y-axis. It's the area where it's literally bounded by. You can't escape. If you're in there, you're not going to get out. Okay. Now, so the formula is the volume is 2 pi integral times the radius times the height times d something. Since we are revolving around the y-axis, I put a vertical strip. That means the base is delta x. If I would have put, say, a horizontal strip, then it would be delta y or dy. So now we have to find the radius and the volume. We know it's dx. We know it's dx. Now, the radius is this distance. This piece is put at some x. That distance is just x. And the height is this distance right here, which is y, also known as x squared plus 1. So in here goes x squared plus 1 equals 2 pi. If you distribute, you get x cubed plus x dx. And x is going between 0 and 1. Integrating this, we get x to the 4th over 4 plus x squared over 2. Add 1 to the power, get x to the 4 over 4. There's an understood 1 here. Add 1, get x squared over 2. And this is going from 0 to 1. 2 pi. You plug in 1, you get 1 to the 4th, which is 1 over 4, plus 1 squared is 1 over 2. When you plug in 0, you get 0. When you add those two fractions, you're going to, this is 2 over 4. 1 over 4 plus 2 over 4 is 3 over 4. And the final answer will be 3 pi over 2, because 2 goes into this top number 1 time, into this bottom number 2 times, and 1 times pi is pi, times 3 is 3 pi, and you have 2 in the bottom. 3 pi over 2. Let us try yet another one. Suppose you want to find the volume of the solid form by revolving the region bounded by the following curves. It's bounded by x cubed, y equals x cubed plus x plus 1, y equals 1, and x equals 1. Y equals 1, and x equals 1. Okay, and you want to revolve about the line x equals 2. Revolve about the line x equals 2. Okay. Now, if y is 1, okay, here is your x and y axis. One curve is y equals 1, which is this line right here. Another curve is x is 1, which is right there. And the curve. Well, when x is 0, the curve's at 1, because 0 cubed is 0, plus 0 is 0, plus 1. 0 cubed plus 0 plus 1 is 1. And then it's going to get bigger. You plug in bigger x values, it's going to get bigger. You plug in smaller x values, it's going to be down here. It's not going to be trapped by, the area won't be trapped. It's this area right here that we're concerned about. Okay, make believe the graph was given. Now we want to revolve about the line x equals 2. We're going to revolve around there. Okay. Again, it's the area in here that we are going to revolve. Okay. Since we're revolving around a vertical line, x equals 2, we draw vertical strips. This is going to be a delta x. Okay. So the volume is 2 pi times the integral of the radius times the height times dx. Okay. What is the height always going to be? Like any vertical height. What's the height between 2 and 9? It's not how do you calculate the height between 2 and 9? It's just not the answer 7. How are you getting the answer? You're doing the top minus the bottom. Oh, and I made one silly mistake. My strip wasn't that big. My strip was this long. The top value is y minus the lower value is 1. This distance is 1. So it's y minus 1. It's y minus 1. The height is y minus 1. Now, what is the radius? The radius is, as I said a few times, the distance between where you're revolving and the strip. That is this distance here. For any given x, what is this distance? And the answer is just like any horizontal distance. If you go from 2 to 9, how do you find out how long this is? It's the right end point minus the left. The right end, this distance is the same as this distance here. It's the right end point minus the left end point. It's 2 minus x. Okay, now nothing I wrote is wrong, but if you're going to integrate with respect to x's, you shouldn't have y's. But we have a way to rewrite y. This is another way of rewriting y. It says y equals x cubed plus x minus 1. Well, if I take away 1, I'll have x cubed plus x. That is, we have 2 pi the integral of 2 minus x times x cubed plus x dx. And x is going from, and how you find that out is you look at the strips. The leftmost strip to the rightmost strip. The leftmost strip is going to start at 0 and it's going to finish at 1. We're integrating between 0 and 1. The first thing you should do is multiply this out. You get 2x cubed plus 2x minus x to the 4th minus x squared dx. And then you integrate this. I'll do that right here. You integrate 2x cubed. You get x to the 4th over 4, which becomes over 2. 2 over 4 is 1/2. Plus, the integral of 2x is x squared. Integral of 2x is x squared. It's 2x squared over 2. And the 2's cancel. You just get x squared. Minus x to the 5 over 5. Minus x 3 over 3. And this is going from 0 to 1. Okay, let me erase up here. And then finish up the math. When you plug in 1, you get 2 pi times a half, because 1 to the 4th is 1, plus 1 squared, which is 1, minus 1 to the 5th, which is 1 over 5, minus a third. And when you plug in 0, you get nothing. So we need to find out what's inside the brackets. It's going to be over 30. A half is 15 over 30. Plus 1 is 30 over 30. Minus 1/5 is 6 over 30. Minus, and 1/3 is 10 over 30. And I can reduce a little bit there. So now I have pi over 15, and I figure out what's in the brackets. 15 plus 30 is 45, minus 10 is 35, minus 6 sounds like 29. So the final answer is 29 pi over 15. Okay, let's try at least one more. The radius is the distance between the vertical strip and where you're revolving. And the strip is always parallel to the line you're revolving around. Okay. So why don't we derive the volume of a cone? Now, if you have a cone, a right-hand cone, that is, this line splits the cone up in half, you have a radius, and this distance will be the height of the cone. The cone, it has a radius, which is that distance, and it has a height. Okay? So, if I take this line, and I revolve it around the x-axis, if I revolve around the x-axis, I will get a cone. Now, this distance should be h, and that distance should be x. Well, that tells me that that point is h. Maybe I said it wrong. This distance is h, and this is r for radius. That point is hr. And the point here, of course, is 0, 0. So I can find the equation of this line. It's y equals r over hx. Okay, so I'm going to revolve around the x-axis. So what I do is I draw strips parallel to what I'm revolving about. Okay, so here's my strip. And we know that this is h. Okay, so let me get rid of the bottom and let's work this out. We know that the volume The volume is going to equal to 2 pi times the integral of the radius times the height times d something. Well, since the thickness is going up and down, that's a dy. Okay. Now, let me just remove this because it's in the way. Remember, the equation of that line is y equal r over hx. Okay. So, the question is, what is, excuse me one moment. Oh, okay. The question is, what is the radius? The radius, as I said many times, is the distance between the strip and the line we are revolving around, right here. This here is the radius. But that's just y. The radius is y. Now, what is the height or the length of this strip? How long is that? Okay. And the answer is going to be h minus x. H minus x. But if I'm integrating with respect to y, I can't have x's. But this tells me right here that x is h over r y. hy over r. So I have 2 pi, the integral of y times, well, let's calculate that. H minus h over ry. That's h and that's x. And I can pull out an h. And I have 1 minus 1 over ry. So why don't we do it that way? I can factor out an h from here, and I'm left with 1 minus 1 over ry, dy. And I will pull the h out in the front, 2 pi h, and then I have 1y, the integral, I have 1y minus 1 over ry squared dy. And y is going from the lowest strip will be at 0, and the highest strip will be at r. It's going from 0 to r. And this gives me 2 pi h. The integral of y is y squared minus the constant 1 over r. And the integral of y squared is y cubed over 3. And this is being integrated between 0 and r. And let me finish up here. 2 pi h. Now, when I plug in r, I get r squared minus r cubed over 3r. And of course, one of the r's will cancel. And when I plug in 0, I get nothing. So I have 2 pi h. From inside the brackets, I will factor out r squared. And then I have 1 minus a third, which is 2/3. So I have 2 pi h r squared times 2/3. 2 times 2/3 is 4/3. I have 4/3 pi h r squared, better known as the volume of a cone. And we derived it. Okay, good luck with this stuff.